Ladies and gentlemen, hello and welcome back once again to the briefing room. My name is Eric Cavanaugh. I will be your moderator for today's event, in which we're going to talk all about one of the hottest topics out there in the field of managing information. The title is Time to Fly, Why Predictive Analytics is Going Mainstream. So we'll go ahead and dive right into the slides here. There's a slide about yours truly and enough about me. As many of you know, the mission of the briefing room is to reveal the essential characteristics of enterprise software. So what we do is we have a forum where we do live analyst briefings. The analyst and vendor do not coordinate before the show, and the reason is we want to have a nice organic conversation, the kind that you get when a vendor gives an analyst a briefing. So we line up different topics every month, and then we line up sponsors to step into the briefing room, talk about their technology, and field questions, and no questions are off limits. So a big part of this process is the audience Q&A. So please don't be shy, folks. Send in any questions you want. We'll make sure they get answered during the event. If they don't, for whatever reason, we rarely miss anything, but feel free to email me after the show. But we do try to get to all the questions during the Q&A. So I mentioned we do a different topic every month, and the reason for that is we're really trying to put ourselves in your shoes. And as you probably know, enterprise software is typically not terribly inexpensive. Some products and services are less expensive than others, certainly. And one trend we're seeing in predictive analytics definitely is the cost curve bending down, which is good news for anybody who wants to use this stuff. Because as I think many of you know, the traditional or sort of long-standing vendors in the space who sell predictive analytics, companies like SPSS, which of course was bought by IBM, or KXEN, which is a little bit more lower priced as I understand it than some of the others out there, or of course SaaS Institute. Those solutions tend to be very, very expensive, and they also tend to be pretty complex. But the point is we do different topics every month, but the same topic within a month. And the idea is that way you as an end user can get apples-to-apples comparisons so you can make a good determination about which tool is going to suit your needs. Next month is actually a catch-all category. We'll do innovators. We have Teradata lined up and a company called Xero, which is very interesting. I have to say it's CIRRO.com. Check that out. It's going to be a very interesting briefing room in a couple of weeks. So the cloud, we're talking about cloud computing this month, and obviously lots and lots of functionality is coming from the cloud. There is almost a reverse gravitational force that is occurring out there, pulling functionality, pulling data up into the cloud. There are many benefits, obviously, to cloud computing. You don't need to worry about software upgrades, for example. That's all taken care of for you. And really, speed to value is one of the key characteristics in terms of what is good for the end user with cloud computing. And with predictive analytics, it makes a lot of sense to do some of that stuff in the cloud simply because in the cloud, typically, you can scale very easily. Most cloud solutions are very scalable, so you can ramp up very quickly and ramp down very quickly, and that's usually the way it goes with cloud computing. But it's very interesting that a lot of companies now are focusing on cloud-based delivery of services, not just predictive analytics, of course, but all kinds of other services. But what we're going to talk about today is how cloud can be used for predictive analytics. So there are lots of different steps to that process, as many of you know. Of course, you need to have the data. You need to build predictive models. You need to do regression testing. There are a lot of different steps along the way to effectively do predictive analytics. And let's face it, it is not for the average everyday information consumer to build predictive models, to test models, to achieve lift. Of course, that's the whole goal with prediction power, is you want to achieve lift. So, for example, in a marketing campaign, if typically you get 3% click-through on your promotions, you're looking to get 5% click-through. If you typically get 2% sales, you're looking to get 3% sales. And obviously, one of the things to keep in mind is you need to be able to scale out in order to maximize the value of that lift. So if you don't have enough girth, if you will, or enough force, enough resource behind your efforts, predictive analytics is probably not going to be for you because, again, if you get that 20% lift or 15% lift or 10% lift, if you magnify it out across a very large program, whether it's marketing or sales or some other objective of the enterprise, that's where you get the most value from that lift. But you want to make sure you get it right before you get into all that time and effort. So the analyst today is our very own Robin Bloor. Very pleased to have him online today. He's certainly been studying this field for a long time, gosh, about 30 years or so, and for those of you who don't know, Robin used to build systems himself, so he's not just sort of a chalk talker, as I've heard some people describe the role. He actually has built systems. He knows a thing or two about how to do all that, and that gives him a lot of perspective for looking at different vendors, understanding what kind of solutions they provide, and being able to ascertain which ones are perhaps a bit more advanced than others. So today we have Perceivant in the briefing room. Perceivant is a software-as-a-service-based big data analytics platform. So the platform delivers real-time access to disparate data sources, and of course you've heard all about that from a variety of companies these days. This whole world of big data is truly changing the nature in which applications are built, and we'll see about how this kind of stuff can be used today in software as a service. So Brian Rowe is online. He is the CEO of Perceivant. He's been an entrepreneur for the past 10 years and started developing internet-based applications way back in 1990. It's a long time ago in internet time. So he's been responsible for pretty large budgets, so he knows the reality of stress and making sure stuff gets done and gets done effectively and gets done on time, because when it doesn't, that's when trouble looms, folks. So here, I'm going to go ahead and pass the keys over to Brian Rowe, and with that, Brian, just click on that slide and use the down arrow on your keyboard to move through the slides. The floor is yours.
Great. Thank you very much. I'm going to go ahead and jump right in here to telling you a little bit about who we are and why we sort of got into this space. Like you said, there are just so many vendors and buzzwords right now. I think it's important to understand a little bit about where we came from and how we got here a little bit, and that really uniquely defines our solution. We were actually at a company called iGo Digital, and I'm not sure if you're familiar with iGo Digital at all, but they served 8 of the top 10 retailers on the internet, the highest traffic websites that are on the internet today, so Staples, Best Buy, and so there's big data experience happening in 2004 when big data didn't really exist, and so there weren't as many solutions that you could go buy off the shelf, and at that time, if you think back, there weren't really many at all. NoSQL was very new in these things, and so we realized we had some problems that we were going to have to solve on our own, really, and that's a little bit about our sort of our heritage, if you will, came from having to solve these problems before these solutions really existed. Even cloud computing at the time, Amazon was even new to offering their services, and we were in traditional data centers waiting to move ourselves to the cloud. And we had about 5 terabytes of data, which at the time would have been a lot of data. Nowadays, it's pretty easy to surpass that. We were growing at a rate of 20 million records a day, because we were monitoring every click that happened on, like I said, Best Buy, CompUSA would have been a site back at the time, Procter & Gamble in multiple countries. So it was a lot of data for then. We were receiving the data in all different types of formats, and it was coming from different sources. So some of it was transactional, some of it was via FTP, it was Bash. And all that data had to be joined, cleansed, analyzed, and we were a recommendations company that provided personalization. So we had machine learning algorithms that had to get through all this data and really look for patterns. And what we were predicting was, what's your next purchase? And so part of that was transactional in nature. But another thing that had to happen is, as you said, well, we had to look at the success of those algorithms, and so there was need for reporting on that data. And what we quickly found was that reporting on data in terms of prediction outcomes and just general analyst and reporting needs are very different than operating a predictive algorithm and the transactional needs of software. And so we had these sort of big data problems in a highly transactional environment that had to happen in real time. Actually, in under 100 milliseconds is when we had to finish our prediction and serve an answer. And many times we would go look for a solution in the market, and there were lots of vendors that had potential solutions, and I don't think we'll name them now, but you're pretty common or familiar with them and who you work with today. There are lots of choices, but even when we looked at some of the lower cost solutions, it was still going to be about $250,000 and up to try to start solving some of the challenges we had. And as a cash-constrained startup, it just wasn't an option for us. We had outgrown our traditional SQL databases. They could not handle the loads. They weren't set up to do predictive analytics on the data. It just wasn't going to work. And so we really just went out and started learning and building solutions and really looked to the open source community to see what was cutting edge at the time. And so as you can imagine, we investigated all the buzzwords, Hadoop, Hive, Elasticsearch, Mongo, Cassandra, over different periods of time. Each of these things we've tested and tried. We looked at elastic computing in the cloud with Amazon, and Google way back then didn't have much in the way of offerings, even though they do now. But that's why you sort of see them off this list, because even Google hadn't really had advanced solutions, 8 years ago, 6 years ago. Okay, and so we also had to start to talk to companies in the indie market and say, how are you solving these problems? What are you doing? And we realized that a lot of the people in the market had the same problems that we did, and there really wasn't solutions for startups in particular, or even for small companies. And then we realized mid-sized companies have challenges, and even some big companies were having challenges. And so when you really look at predictive analytics, as you said, there's a lot of work to do. You have to prep this data, so clean and flatten it. You need to visualize and analyze that data. That helps you find what you might want to make a prediction on. This is just part of the visualization of the data and looking at what is it that you want to predict and what factors might be important. That's part of the analysis. And at some point, you have to implement the actual result. And as you said, you need to backtest that result to try to determine what your success rates really are, what your error rate is. And the last part here, these last couple of steps, we think are really value add, which is you really have to integrate these predictions into your business process. You can't. It's not enough to go out and pay some PhDs to come up with a formula if you can't integrate it back into your daily process. And so operating that in a scalable compute infrastructure is very important. And then again, you need to be able to measure your result and go through a continuous improvement process. And so there's a lot of components of this, and really one solution didn't meet all the needs on all those steps. And so as we looked at the market, you can start to see that there was a lot of big problems with big data, but not the least of which was that there's a talent gap. And so even if you try to hire people to help you solve those challenges, McKinsey estimates that 60% of the projects won't have the talent. And so there's talent shortage. And we had some homegrown talent because we had years of working on these technologies. People with Hadoop, Hive, Pig, Elasticsearch, et cetera. These people are in high demand right now as these technologies become more popular. The other sad fact we realized was that data preparation takes about 40 to 50% of any predictive analytics project timeline. So we thought, well, certainly we could agree to that, but it must be getting better. That time must be getting shorter. But the Data Warehouse Institute said it's actually getting worse because of the amount of data growth. The data prep time is actually taking longer. And a lot of the vendor products that we looked at and evaluated had sort of avoided data prep in terms of their predictive solutions. The assumption was data was already prepped in a lot of cases, and it certainly wasn't at some of these volumes that we were looking at. And then, of course, social data explosion just compounds the problem in how you store and analyze just terabytes of data. And so we found out that there was quite a few hurdles for us to get over, and a lot for other businesses. And so you say, you know, is it worth the effort? And I think that's, for us, it was our business to make it worth the effort, because we were producing predictions, essentially targeted ads, if you will, for very large companies who could spread incremental growth over millions of shoppers. And it literally meant millions of dollars in improvement to their top-line growth. And there's some examples, I think, though, outside of the customers we had at IGO Digital, like a Target, and I think this is a very popular case study that people have seen today, is Target was able to look at shopping behavior of people and predict which people were pregnant or early in the pregnancy process because of their buying habit changes. And so they were able to target or market to them about their upcoming purchase needs in a more personalized way, and you sort of increase their top-line growth because they were able to cater to the needs of these people. We're also looking at things like combining credit scores with channel data to price loans. And so how do you make loans more profitable by channel? And so for even mid-sized banks, pricing these loans appropriately can mean millions of dollars in top-line growth. And so, you know, these insights can have huge impacts on your business and your profitability. And we realize that a lot of mid-market businesses just had no access to these tools. And really, that's where we started to see an opportunity that people were interested in the knowledge and the experience that we had in helping them take predictive analytics into their business in a place where, quite frankly, they just didn't have a data scientist. So Target has a team of people that have data scientists and can do this work, so they can buy a SaaS and really work through and have expertise in that tool. And spending the kind of money it takes to do that for them isn't necessarily cost prohibitive for them, but for a lot of people, it really is. And so that's where we come in. That's where we're really trying to help people. It's a company that doesn't have a data scientist on board, but maybe needs to compete with those guys. As we have in our, we sort of have a complexity value chart here on some of the services that we offer, and we can really help people start literally at reporting and move up the complexity and value spectrum by adding the dashboards or the OLAP and data mining and then the predictive analytics. And it really is an evolutionary process. We can help people get launched within 30 days. Because we're in the cloud collecting data and sending it to us, we've actually had people load data within just 2 or 3 days and start being able to use some of the tools that we have. And they're doing it at a 50% cost savings compared to purchase package solutions. And so, you know, one of the things that we're trying to do is offer essentially 80% of the functionality at half the cost, and try to really find a place where companies that didn't previously have access to these types of tools really could get access and make an impact to their business. All in an environment that was secure, that they could access anywhere, even in a mobile device, that they could not have to worry about the scaling, and then most importantly, integrate back into their existing systems and business processes. So we think that fundamentally producing an algorithm that is predictive is only as helpful as it is that can be implemented in your business, and of course measured. And so at a high level, you could have multiple data sources. Maybe it's your ERP system, maybe it's Salesforce.com data, maybe it's Twitter. All that data can be driven into the Perceivant platform, and we can take that data in batch or transactionally, so either through HTTPS or SFTP, and you can send it to us in a secure way. And then we provide an interface where you can get reporting, maybe dashboards on key elements that come into that data, use our OLAP tools, and see the outcomes of the predictive analytics. And I'll talk a little bit more about predictive here now. So we view predictive analytics as a not one-size-fits-all opportunity. We are not trying to offer or rebuild a package like R or SaaS. What we're doing is looking at these engagements as service engagements. Problem. We have multiple machine learning tools that we can work with, and what our goal is to help you determine the right combination of the human expertise and machine learning tools that can maximize the result for your problem that you need to solve. And so it's very much a process where we intend to work with you on creating a solution that's right for your business, understanding the fact that you don't have statisticians at your company or data scientists already at your company to help with these problems, okay? And so we'll deliver the formula to you, or the prediction, but we'll also implement the formula, and then we can operate that formula on the data that comes in on an ongoing basis. So you're not left to figure out, well, how do I now go ahead and implement in a computing infrastructure the algorithms and predictions that we've built out here. So it's not just a, do the engagement and leave you alone. It's very much helping you to operate the result on an ongoing basis. And we have capabilities in terms of our machine learning that we can talk about more maybe in the Q&A, but really an approach that helps identify hidden patterns in your data that are possibly not found in traditional approaches. And we'll talk about our partnership with Emerald Logic as well, which really can comb through your data as it's in our system already to identify these hidden patterns and produce the formulas we need very cost effectively compared to historical methods. So a quick case study. We worked with an educational institution that was spending about $500,000 a year on BI tools and infrastructure. That doesn't include people time. The capabilities that they had were very unresponsive and slow due to the amount of data that they had. They had no predictive capabilities. They did an RFP to try to find potential solutions with common vendors that you probably know by name, well-known household names. But really the result of the RFP was about $1 million and up, okay? And that was just price prohibitive for them. And so they found us. We started working with them. We were able to load their data in 2 weeks. So the RFP opportunities would have been 3 months to get a proof of concept. We had data loaded in 2 weeks. BI tools out of the box satisfied many of their reporting needs, their needs to slice, dice, and analyze data. We had real-time query capabilities that had not previously been possible for them. We're in the process of converting many of the existing reports they had. Some didn't need to be converted anymore. Some did. Some, were not as necessary. Didn't need to convert them all. We can also make new reports for them, including predictive reports. So some of these things would be looking at the impact of social media on student happiness or dropout rates. And one of the other things we were able to do is create a history from the ongoing data. So in their particular instance, they didn't have a history. Their data systems were all point in time because a history would cause too much data storage. And so what we're able to do now is on every data change, create that history for them on a go-forward basis and store it, because we're able to store the terabytes or eventually more data they'll need to keep that history. Overall, this solution reduced their cost by 50% of their current solution. So it was faster to get running, it was cheaper than their existing solution, and it was far cheaper than any of the comparative products they looked at in the market. So, our thought is invest in ROI, not R&D. That's the thing that we'd really like to talk to is, we're not trying to have the most complete statistical package or predictive analytics package that we just hand to someone and say good luck. It's really about trying to get people on board as fast as we can to show them results as quickly as we can to improve the ROI. Monthly prices starting even at 2K range, depending on how much data you actually have, and really help you leverage a sizable investment in the data that you already have. I have an architecture slide that we can leave up as we start to talk about questions and answers. It might be a little bit hard to read, but maybe if you download the slides. We have a custom process to import data very quickly. That data is transformed, it's flattened and made suitable for analytics. In that flattened storage area, we can perform the reporting, DI, predictive work. That then feeds into, it's a closed loop process that would then feed into the new data that was coming in. So for example, the predictive algorithm that was implemented, when new data came in that was supposed to have a prediction on it, that computation would be made and that new predicted value would be added to the data set. And then we offer you a variety of ways to get at your data, either through our UI, through reports and dashboards, export to Excel, or through our data access API. And we think that data access API is really important to integrating back into your existing systems. I think that's probably what I wanted to get through right now before the Q&A.
Okay, let me go ahead and hand the keys of the car over to the venerable Robin Bloor. And Robin, the keys are now yours. Just click anywhere and move the slides with the down arrow on your keyboard.
Okay, that seems to be working. There's a picture of me. You don't want to look at that. Okay, what I thought I'd do, because I looked through the slides before the presentation, I looked through Perceivant slides, and I thought, okay, something's going on, and it's been gradually kind of going on as far as I can see for a fair period of time, and this is really that the technology of Hadoop and things associated with Hadoop are getting actually involved as a regular feature now in BI. So I'm just presenting the idea that this is a new universe of BI. That, by the way, is a picture taken by, the background is a picture taken by the Hubble telescope, and it's called the Jellyfish Nebula. I've no idea whether that's got anything to do with BI, but look nice. Okay. Let's talk about open source and the cloud and how it relates to BI. First of all, it seems to me that open source and the cloud walk hand in hand. In some ways, well, actually, in several ways, they undermine the traditional database business model. And they do that simply because nobody, when they're provided with a cloud service, actually starts to nickel and dime about which database is being used. And nickel and dime about and they should do, of course, about the performance. And they may, in one way or another, get a service that they're not happy with, but they don't come to whoever's provided it and said, you used the wrong database. They don't care anymore. They're not going to have to administer that database unless they bring it back in-house, so, you know. Secondly, of course, Hadoop and what I call Hadoop++, because this is all of the now very many components you can put on top of Hadoop and make Hadoop do funky things like pretend to be a database. You know, pretend to do, well, not actually pretend, behave like a database, behave like an analytics engine and so on and so forth. I mean, Hadoop fundamentally is a file system which is based on key values, which is highly scalable and which you can parallelize over. So, you know, as a base layer, you can do stuff over it, and there are a lot of components now where you can do stuff over it and make it look like stuff that might cost an awful lot more. And all of these Hadoop components, by the way, are fairly much free of charge. So, you know, you can play with it, and you can play with it in the cloud. But particularly, Hadoop has become the staging place for data. In the sense that a lot of organizations I've talked to are effectively pulling in a lot of data from various places and just dropping it in Hadoop and then managing it from there, using Hadoop as an ETL engine to take out extracts and put it in other places, possibly in data marts, possibly in a data warehouse, possibly in an operational data store, but, you know, in somewhere else. So they're using it as a kind of staging place. but not as just one staging place. They're using it as a general staging area, and we've never seen this before. Never happened in BI before. The cloud obviously is a natural prototyping environment. It's low risk because you're not going to pay much to put stuff into the cloud, and you pay by the hour. So, you know, if anything is going amiss with what you're doing, you can always just turn it all off. But, you know, you can prototype in the cloud, and if it works in the cloud, you can keep the BI apps in the cloud. So, you know, that solves an awful lot of problems that may arise with various in various installations, depending on the nature of the installation, because everything is off premises. You don't have to worry about the operations that govern whatever in-house IT you have, because it doesn't connect particularly with them. You just need to be sure of your networking links to the cloud. Other things to say, well, the public cloud is growing like crazy. I mean, you know, it's growing at greater than 100% per annum. It's now very difficult to measure exactly what the public cloud consists of. You have to break it down into little bits. But certainly, the Amazon cloud is growing at a rate greater than 100% per annum. The private cloud is, in my opinion, a gateway drug to the public cloud, but it's also vice versa. You know, if you can do stuff in the public cloud and it works very well, then pulling it back in-house and sticking in a private cloud is not too much of a problem, because if it worked in the public cloud, it will work in a private cloud. So you've got this kind of beautiful bridge that is gradually emerging, where you can throw stuff out, bring it back, and you can get cloud-like capabilities in-house if you buy the associated hardware and software that will do that for you. The cloud, as I've already mentioned, devalues many software brands, and in my opinion, with stuff that's delivered from the cloud, the only thing you can really brand is applications. You know, well, you could brand services, I suppose, but you can no longer brand the infrastructure layers. They are whatever they are. If you've got something in the cloud and it's running adequately, you don't care what boxes it's running on. You don't care whether it's IBM or Oracle or HP or even some server boards put together by the cloud provider. You just don't care. You know, and therefore, you know, the cloud, in one way or another, just devalues an awful lot of the branding associated with infrastructure. You know, it devalues system management branding and so on and so forth. Devalues all of that, and that's actually good, in my opinion, for the customer out there. And of course, open source is beginning to dominate BI cloud deployments simply by virtue of cost, because you can start to mess with it, make stuff happen. And the upfront costs or the add-on costs for using that software are pretty much zero. So, kind of vaguely in summary, for BI users, the cloud plus open source is certainly good enough or better, especially for smaller users. Obviously, larger users that have specific performance targets where the cloud isn't going to do. But it's also a leapfrog opportunity, and I think this is important, because I think to a certain extent, this is something that Perceivant are doing, and therefore a worthy topic of conversation. You know, if you look at the way that BI normally evolves, the first thing you do, I mean, I look at this in terms of these four words: hindsight, oversight, insight, and foresight. And in terms of hindsight, we've been doing that for a long time. There's lots of really good software out there. People have their favorites. But, you know, all you're doing is the regular reporting that's required in most systems and the various operational BI that's required, and we've been doing that for a long time. Oversight is dashboards, OLAP, business process monitoring to a certain extent, and so on. This is also reasonably well established, not as long established as the hindsight stuff, but certainly not much of the technology here is a mystery. It's reasonably well understood, and there are various products out there, including open source products that can do all of that kind of stuff. And the two areas, if you look, especially with small companies or medium-sized companies, that you look, they may have hindsight and they may have oversight to some degree or other. Very rarely do they have anything that could be described as insight, that's true data mining or proper statistical analysis of trends of the data that's in-house or data that's brought in and relates to their business. And very rarely they do have foresight. And one of the things about the cloud is if you can get an operation like Perceivant to do a lot of the grunt work for you, you can actually go through this actually quite fast. In other words, you can leapfrog the situation that you were previously in. So, finally, what I thought I'd do was I thought I'd put together a very, very rough diagram, but it's just to try and give a flavor of what seems to be happening. You know, I look at this on the left-hand side. You have Hadoop, all the Hadoop plus stuff that allows Hadoop to impersonate various stuff. Plus, you have ETL that's driven by Hadoop, and that can be dropping data into NoSQL databases, or it can be dropping them into operational data stores, ODS, or the enterprise data warehouse. It can do that. It can be a feeding point for that. You've got various BI middleware. That can be very complicated, and an awful lot can go on there, from data cleansing through to metadata management and so on and so forth, getting metadata models that apply to the whole enterprise. And that can be very complicated. However, you know, now the BI middleware has to think in terms of applying to everything rather than just the EDW, which is where most metadata management stuff was done. And cleaning has to be thought, I think, as a general thing rather than various data cleansing activities. You have on the right-hand side, obviously, you throw up data marts to provide, and I've just got across the top all of the various BI capabilities you want. And they can go now, depending upon, you know, the nature of the specific application thereafter. They can go to a NoSQL DBMS, or actually what I would call a new SQL DBMS, which is, you know, a column store with an awful lot of muscle, an awful lot of capability up to the petabyte level if they really want it. You know, so they can have a fast engine that's not typical relational engine, and also they can remain with operational data stores and EDWs, which tend to be relational engines. They can pull data marts off. They can go direct to Hadoop for any of the things that Hadoop does well. And you have what I would describe here as you have the bones, the infrastructure for a data layer, and the infrastructure for an application layer for the BI universe. And I think we're just going to see the world gravitate towards that. Okay, so now I'm going to go on and start asking Perceivant some questions. But before, there are a number of things in the presentation, so before I resort to any of the questions that I have lined up here, some of the questions that I wanted to ask. First of all, I know you guys use specific technology, but you talked about a flattened storage area. Well, I understood immediately by that, my understanding may be not correct, is that, you know, when you create BI stores, you're normally flattening the data. In other words, you're going down to kind of snowflake schemas. So I kind of wanted to ask you, what do you actually mean by a flattened storage area? Do you mean that this is going into Hadoop or into something like Mongo or into a regular database? What are you actually putting in there, and what does it consist of?
Yeah, we use many of the technologies you talked about, but when we talk about flattening the data, what we're talking about is taking what might be what was previously a relational structure of your data, where you know, all the duplication was taken into account, and so you optimize the storage to reduce the amount of disk space that it took up, and it was efficient for doing that, and it was efficient for creating integrity and creating updates. When I talk about flattened, what I mean is, if we talk about a piece of data, for example, might be that a user is enrolled in a class in a college maybe, or they have a credit score classification that means it's in a certain range. And traditionally, you would link to that in some relational store, and then so it would only be stored once for that value. But what we do is we flatten it and duplicate that storage, so it increases the amount of disk space it takes up, and that data is duplicated into every record, essentially. And then when an update happens, you may have to update every record with the instance of that information. And so we're handling that all behind the scenes, of course, but it really means that we've taken the relational aspect out of the data, that we have dramatically increased the size, but we've also put it into a format which machine learning tools can operate on it effectively, and that is essentially it's a NoSQL, unstructured, highly indexed solution that's on the back end.
Oh, really? Does it have a name, or is it your own construction?
That part of it is our own construction, but we do use many other popular tools on the market to get the data in, out of there, and support our other functions.
Oh, well, that's kind of interesting. And my understanding is that you basically flatten things down to a star schema or a snowflake schema, so that you will get duplication by doing that. But a lot of people do that anyway in data warehouses. Certainly, they do that in the column store databases. So you have your own engine in under. The other thing that you mentioned was data preparation, and I thought it would be nice if you explained that a little bit more than you did, because I kind of wanted to understand exactly what you meant by it, the kind of things that would go on to the data in the data preparation stage.
Yeah, if you look at a lot of how a predictive application would start, if you were going to say, we're going to try and do some predictive analytics around a certain area of our business, you would go through a process where you would first have to find the data, and it could be anywhere in your business, and it might be in 2 or 3 systems. And so you'd have to identify it, and then you'd have to pull it together somewhere, and then you'd have to find what the common join keys were between the data sets. And then again, like I said, you would have to transpose that data into something that was acceptable to be worked on in an analytic tool. And then you'd, of course, have, unfortunately, data cleansing problems. And so that would all be what we would look at as part of data prep. And you would find data missing, and you'd have to go maybe find gaps where the original data set was, maybe to get those gaps filled. So there's this whole process that most people don't think about that really involves just structuring the data in the right format to be used for analytics, cleaning it, joining it, flattening it, those types of activities that are the sort of the drudgery, if you will, of a predictive analytics project. It's less the actual analytics at the end, and most of the time is spent prepping that data set.
Yeah, right. I can understand that. I mean, I would simply classify that as ETL of a certain kind plus data cleansing, but absolutely, there's a lot of effort in that. And as you point out, some people do the effort after they've built the system and they realize it's not working properly. So it's much better to do it ahead of time. Another thing that you mentioned that I'd like you to comment slightly more on is that there is a problem in the whole of BI in that you can put in BI capabilities and people can use them and find things out. But you talked about embedding it in business process. So this is what we talked of before on the briefing room as actionable business intelligence. Can you go through just the process that you would go through with a customer in order to ensure that, aside from delivering the various BI capabilities, you actually ensure that it's used in a rational way? Because I think that's a significant part of the value, because people do implement this stuff and then not use it properly.
Exactly. And so there's a whole host of ways to inappropriately use data. And so, part of our process is really about trying to understand what the goal of the prediction would be and what the business impact is. And so the conversation that we like to have up front is really a tangible, how is your business going to get a better ROI out of this? Is it top line growth? Is it profitability? So we're looking at margin challenges that you have, and then making sure that we're applying the right technology to do that. For example, when we talk about a project that we're working on where you look at loans and what rates to offer, this has to be integrated into their business. They only get so much time in some of these channels to actually deliver the right loan rate. And so we're not necessarily automating the process of saying, here's the loan rate for this person, but we are able to give a guideline that says, for these factors, this rate should be, we think, over here. And the loan officer obviously can still put in whatever number they want, and they have different process for doing that. But it's important for us that they understand, what these values and recommendations from their predictions mean, and then how they're actually going to be used in practice in the field, so that when they see the values or their prediction come up later, it's being used in the right way. And so, for example, and I'm just pick on Google Predictive for a moment, you could use Google Predictive to predict the right loan rate, but that might not necessarily be the right choice, even though they'll give you a number back. There's plenty of good reasons why you might use Google Predictive, but in this case, it's probably not the right one. And so we really help them work through that and make sure that we can give them even a real-time interface where they can query the system with certain parameters and get the answers back to use them, at runtime in their business.
Okay, so if I understand correctly, one of the things that's going on here is that you actually discuss and walk through the business process before you ever get around to building or delivering anything, so you properly understand where it's going to be implemented. Is that right?
Absolutely.
Okay.
For the predictive piece, absolutely.
Well, I was going to say the predictive piece, of course. Predictive analytics, if properly applied, if you can find good targets for it in a business, predictive analytics can have extraordinary ROI, as actually you've pointed out by some case studies. So the other thing that I wanted to ask before I got onto my list of questions, which I'm probably going to have to tear through, but it's really, if you could give us an idea, I know you tend to deal in the mid-market, and because you're in the mid-market, you have the potential, given the capabilities you've got, to deliver a whole BI from top to bottom, from basic infrastructure to every single capability that anybody could want. But nobody ever does that, I shouldn't think. So I was kind of interested in what your typical project looks like. They hire you because they want something particularly done. You're going to build some basic infrastructure because that's the way you do it in order to provide a BI capability. But do you tend to have like a single target? Is someone normally coming to you and saying, well, we need something predictive, or we need some kind of data mining kind of thing done? Or do they come to you and say, help us? What can you do?
No, I think most typically right now, people in your chart, in terms of progressing through, they're really coming for the data mining, that level, sort of stage 3, if you will. And they have aspirations of prediction, but they're not quite ready yet. They've got a lot of capabilities already under their belt. Want to make sure that if they're going to send us all this data, that no reason to have those functions live somewhere else as well. But I would say most often it's in that phase that people are talking to us, and they're looking to get an accelerated path through that phase to prediction.
Right. Yeah, and then this is what I talked about as leapfrogging. And I think it's a great idea for those that can do it because, it seems to me that pretty much, and you can have an opinion about this as well, but it seems to me that the hindsight and oversight stuff is now pretty well established in an awful lot of companies. I know there are companies that are behind that don't have, for instance, OLAP capability and really should, and so on and so forth. But the gold is in the insight and the foresight. I don't have any doubt about that. So let me just, before I hand you back to Eric, before I throw our audience at you, let me just first ask a few things, and if you could just give very swift answers. You obviously have built a fair amount of this stuff yourself. What would you say in terms of the components? I mean, is pretty much all that you've talked about stuff that you've done, and you just bolt in, you know, if you need Mongo, you bolt in Mongo. Obviously, you're using Hadoop. You know, are there any other major components that you tend to use all the time?
Yep, we use Hadoop, Mongo, Elasticsearch. We export to Google BigQuery. Those are probably the primary technologies. Of course, there's general infrastructure like MySQL or you know, queuing services and things like that that would be typical in an infrastructure like ours.
Okay. And are there any aspects of BI, because I've just gone through the BI applications, but there's a lot in BI. Are there any aspects of BI that you wouldn't cater for? If somebody wanted a genuine real-time analysis, you know, CP stuff, what they call complex event processing, is that something you would happily pick up and do, or is it something you'd simply say, not us, go to somebody else?
Yeah, I think there's a couple of things. There's you know, like I said, we're trying to deliver maybe 80% of the functionality at half the cost, and so certainly some of the you know, very real-time functions we would avoid right now because they tend to drive different cost factors, and we're certainly not a governance or data management solution. Not that, you know, you probably couldn't make the leap to see where we, you know, maybe could do better than, you know, if you don't have anything in place today to secure or manage access to data, but that's typically not something that we're doing today.
Okay.
You know, we talk about doing things in 15 minutes, about business time. So giving yourself about 15 minutes for a piece of data to come in and get an answer back out is, and we can improve that for people who want to, but getting to sub-second timing is probably not where we're trying to be right now.
Okay, well that's interesting. And I mean, the other question, this is, I know the larger the organization, the more complex the data, and therefore the more complex the BI would be. But, you know, from the point of view of simply scale, I don't really see any reason why you couldn't do this for extreme scale, in other words, very large amounts of data, and therefore very large organizations, as long as the data wasn't too complex. Is that the case? I mean, is this scales? And if I said, oh, I want a petabyte, you know, I actually have, even though I am not a very large operation, I actually am going to be rolling up a petabyte in the next couple of years. Will you be able to handle it? What's your answer?
We have never done a petabyte, so but 100 gigabyte or 100 terabyte, I mean, you know, might be, you know. So, but I think you're right. The scaling problem is really not about the technical solution. It's really about a fit of the way that we've tuned our software, and we've to give us the price performance benefits that we have. And a lot of the larger companies probably have people on staff that they want to do a lot of this effort. And so we're really geared towards people that don't have the staff and need the service component of what we do.
Okay. In which case, I'm afraid I'm going to have to give you to our audience. Eric, would you like to take over here?
Yes, indeed. So we've got a number of really good questions here. So, Brian, I'm just going to dive right in. We'll go kind of a first come, first serve. Let's see, one of the attendees writes, the tool itself is not sufficient to leverage the outcome of the analysis. There are several assumptions out there regarding the skills and qualifications to be a good predictive analyst. What are some of the skills and qualifications you can highlight for that particular role?
You know, we're located in the Midwest, so we typically work with the IU scientists at PhDs that come out of, you know, IU, which has petabyte size data scale and one of the biggest machine learning environments in the U.S. now. You know, our focus has been, you know, looking at some of the qualifications in terms of the research work that they had done at university in their tenures there, and are they able to work on business problems? And so, typically some of the people that would get to this level of expertise value the result as being a good result, but that has sort of beauty in itself, if you will. And what we try to focus on with the people that we work with are, can they look at the long-term value of the result and make it practical for a business? Can they make the leap from theory to practical implementation that adds business to a value on an ongoing basis?
Mm-hmm. And I talked at the top of the hour about some of the more common use cases in marketing, certainly getting better open rates, better click-through, in lower attrition, for example, of customers, in better sales, for example, getting people to buy more products with next best offer and that kind of thing. What are some good examples outside of those sales and marketing realms where predictive analytics can provide some lift?
Yep. Loan rates, so evaluating credit scores. There are several healthcare applications that are out there today in terms of predicting recidivism. There are predictions, and maybe Patrick can also talk to some good examples who's on the phone with us, but predictions of disease potentially, or likelihood to be susceptible to, say, diabetes. So really, there's a lot of things beyond sales and marketing that traditional businesses can do that haven't been tapped really yet.
Okay, good. And in terms of big data, I mean, this is one of the obviously the most used and arguably abused terms in recent history in the field of data management. I'm curious to know, what kind of preparation do you wind up doing to big data? And I'll just give you a quick example. Maybe we'll stick to healthcare for a minute. I've gone on a number of webcasts over the last several months where various vendors and consultants and analysts have talked about use cases in scraping, for example, Facebook pages and other social media sites for information. And quite frankly, it's kind of a creepy story, but one of the guys who talked about it said that some hospitals are now using social media analytics to see if, for example, someone who just had a heart transplant is going out and tweeting from Billy Bob's chili dog stand and using that information against him to say, hey, you're not supposed to be eating this kind of food. Is that the kind of thing that you're seeing? And if not, can you give an example of big data used for predictive analytics, and how do you process that? How do you stage it and get it into a condition that can actually be used by predictive models?
Yep, that's a good example. Healthcare, in particular, has some challenges right now as the new Healthcare Act comes out, where you're really graded on the care of the person and the outcome, and not necessarily having them back in where I can charge you for another visit. And so this idea that, it's okay to follow up with you now on a 30, 60, 90-day program is becoming very popular, and we're looking to actually partner with another firm that will use some of our data that we could provide in a case like maybe the one that you've talked about here, where they're going to provide either training, assistance, and follow-up for your specific healthcare challenge. So, for example, if you had diabetes or were diagnosed with diabetes, we can monitor the glucose levels that come off the machines, your weight, that come off the different devices you have in your home, and then transmit that data. And it does start to get a little bit creepy. We're not doing it in a social context for healthcare yet, but we are monitoring these various devices and then proactively reaching out to them and saying, maybe you ate the wrong things yesterday because, your glucose, blah, 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 and trying to get them on the right training programs to keep them out of the hospital will be the new goal. To Twitter in particular, we do monitor Twitter and Facebook and we can store the terabytes of data required to bring that data in, process it, and then sort of make it available to you in our BI interface. And most typically what we're doing there is more sentiment type analysis and giving people an opportunity to respond to negativity or correlate the negativity to some other business event. Like, for example, if it was for a restaurant, negativity in your scores on Twitter and its impact to revenue.
Okay, here's another good sort of general question. One of the attendees asks, how do you sell a predictive analytics project to people who don't really understand about statistics or predictive algorithms? How can you make them understand that you are not offering a crystal ball?
Well, you can't make people, maybe not understand or understand, what they don't want to understand, I guess. But this is a real challenge, right? Because it goes back to the Google Predictive maybe, or some of the other more simplistic models where, what we really try to do is understand the business goal more than just, is it about predictive analytics? And sometimes the answer is actually insight, not foresight, and simply looking at the historical correlation of information, is the answer. But that's part of the service, and it's not necessarily that we're trying to sell a predictive analyst project. What we're trying to sell is the value add. And so we're very open to saying, if I can increase your revenue by this much, is that what you want to see as an end result? Is that the business driver that you're looking for? And so then we can say, okay, we can implement insight or foresight to create that change. And because of the way we have a platform for collecting all the data, we can measure the result and see the impact of how we've used this data in their business. And so it's just really for us about that. It's about that ROI.
Gotcha. Okay, good.
Brian, this is Patrick. May I comment on that?
Please. Yeah, go ahead.
Please. Yeah. So I'm with Emerald Logic, and we're the predictive analytics partner. The key here is if somebody is not deep into statistics, you're not going to give them some sort of Bayesian model or a linear or nonlinear regression or logistic regression model and say, okay, here's the model, go have at it and integrate it into your systems, right? I mean, you have to have a system like Perceivant that you can take an algorithm or a model that comes out of predictive analytics and make it operational, and that's a big piece of what they provide. What we do at Emerald is we'll take the data that comes out of Perceivant system as an extract, and we produce a predictive model, and we can do that very rapidly. And the way it comes out is as a simple series of formulas or steps that any domain expert in their field, not in statistics, but in their business, can look through and see which variables are used, how are they used, what are the relationships there. And so they get insight out of the model, but then it can be put back into the system so that as data comes in on this business scale of every 15 minutes, they get answers back for decision support very quickly. So they don't have to understand anything about the method that produced the model because they can independently verify it in their data and understand it.
Okay, good. That's a good answer. Okay, here's another very specific question, or fairly specific, I guess. One of the attendees asks, are you mostly dedicated to consumer-type data versus a company that builds machinery? And he notes speed, using tools inside an ERP package results in slow programs. Have you worked in the area of speeding up ERP by pulling out the data faster? And I guess it's also kind of tying into that business process. I'll throw out just another question since we're going a bit long here. One of the attendees noted that integrating with business processes is not easy to do and can sometimes take months or even longer depending on who owns those processes and what technologies are involved. So can you talk about the ERP question and also about how you actually execute an implementation that ties back into an actual business process?
Sure. So I wouldn't say your historical manufacturing environment where you're talking about building machinery would be our typical use case. So I don't want to gloss over this too fast. In the educational environment that we looked at, they actually had an ERP system. It was their enterprise resource planning system for managing their entire business, and it wasn't about speed in that case. But the report and analytics piece was taking about 22 hours to process. And so we took that from the 22-hour overnight process down to, 15 minutes to really see and update new information. In our prior life, speed was the focus, where we were literally making computations and getting results in about 100 millisecond timing. That type of speed it just costs more, quite frankly. And to date, we haven't been looking to opportunities to move our platform to that type of sub-second timing. But we could push it to, say, a minute without much cost difference. But once you get below that, it's really fast. And then integration is through our APIs. We have secure REST-based APIs where if you have, say, most typical for us would be a web-based interface that you already have somewhere where you want to pull the data back through, and you can use, AJAX calls to get to our REST-based interface and pull the data through and see it visually. If you have decision support, you could use those same APIs to integrate to your business process.
Okay, good. And let's see, how do you deal with privacy and security of the data, seeing as that you are hosting this in the cloud? How do you partition different customers' data such that you don't get privacy concerns?
Yep. So you can be in what we would call our public cloud. You can have your own virtual private cloud, so you would be totally segmented into your own environment. And then we can do a HIPAA compliant virtual private cloud. And so, we really haven't had issue there. If you don't want to be in the cloud, then you don't want to be in the cloud. If you're willing to be in the cloud, then we can produce a secure environment that allows for that. We can provide HIPAA compliance in terms of, the transactional logs that track every viewing of each piece of data to make sure that, is an appropriate authorized use, et cetera, and control the security on those data values. But most typically, the values that need to be protected from a HIPAA or from a PII concern are not predictive values. So those values can be obfuscated and turned into masked values because the uniqueness might be important, but they're not predictive, and so we don't necessarily need those values to do the predictive work.
Okay, good. Here's a really good question. One of the attendees obviously has done some of this stuff before, and let me just go ahead and read through the question here. How are your clients using predictive analytics to investigate causality relationships, which are like sniper shots and have a different meaning than observing correlation phenomena en masse that more resemble shotgun approaches? So causality versus correlation, basically. Have you worked with companies using predictive analytics to determine causality?
I'll say one thing, and then Patrick, let me know. So I think one of the things is there's correlation, which we do get, but for example, if we were going to correlate an outage at a certain client where they have, let's say, a power outage that brought down systems, and then unhappiness on Twitter, and then reduced revenue for their service, that's a type of case where we're trying to really look at causality. And Patrick, do you have maybe a better example of how that might be shown to people in terms of what they're seeing in terms of the algorithms?
Yeah, and this is an area where I would say that you have to be very, very careful with any kind of predictive analytics when you're looking for causality. There are models out there by Judea Pearl and others that are used by a few companies, but they're very, very easy to misuse and misinterpret. And, you know, the old saw about correlation does not imply causality is absolutely true, even with Pearl's models. So this is where you really need the business expertise to come into it. And for example, in our work in healthcare, we did a project with researchers in the UK where we identified 22 biomarkers that were novel that are implicated in Alzheimer's disease so that you can effectively screen at over 93% accuracy for Alzheimer's from 3 milliliters of blood. But those blood markers aren't necessarily causal. Some of those may be outcomes of the Alzheimer's process. Some of them may be predisposing genes to the Alzheimer's process. And to tease those out, you need to understand the mechanisms, and that's where the researchers and doctors come in. And it's the same in a business. In Brian's example, what you need to understand is what's going on in the network there. What's going on in the business process and with the customer behavior around that. If you rely strictly on the mathematical models, you can really go astray because you can make assumptions about causality that cause changes in your actions that push you off of a risk cliff. So it's really important here to integrate the math and the expertise of the business people.
Yeah, that's a great answer. That's a real good answer. Okay, good. Let me see. I know I have a couple more questions here, and then we'll wrap it up. So one of the attendees, another really good question: how does your methodology deal with data discovery and requirements, which usually usually requires long lead time in many of these analytic projects in uncovering patterns in the data? And if I understand it, this is where your services come into play, right? You actually help a company walk through the process after identifying what the business needs are. But can you go into some more detail about the methodology for data discovery?
Yeah, absolutely. I see this question two ways. So one way I'll answer, and I think Patrick has a good answer for the other side of it. I think one is sort of looking at data discovery as helping people find the data in their current systems and environment, and maybe they don't have historical data. Maybe they need to use our tools to produce it over time. Maybe they have a certain amount of historical data, but they're not sure which pieces to grab. And so what we can do, because we can load mass amounts of data, is we can help just take, I don't want to say give us all of it, but really load large amounts of data from multiple environments and then use our visualization tools as part of the process to do some of the discovery. But I think where our solutions shine is what I'll ask Patrick to talk about in how we can look at mass amounts of data and really do dimension reduction to produce these formulas. Patrick, do you want to just talk a little bit about how we can look at very wide data sets very efficiently?
Absolutely. So I'll give a couple of large examples, and then I'll give a specific example of how it impacts daily operations. So in terms of the width of the data, we've worked with data sets as large as 1.7 million variables per person in autism, for example. We've worked with data sets as large as 11,000 blood markers in Alzheimer's. And we can very quickly determine which small number of those variables actually matters in the discrimination or prediction. And I can say with certainty that in no project that we've ever handled have we ever had to produce a classifier or discriminator or predictor that required more than 8 variables to do the job, even in very complex healthcare situations. And if I sort of bring it back down to a smaller example with a lot of money behind it, in the payment space, in terms of merchant advances and merchant processing, for example, the typical underwriting process is about 60 questions for a merchant to be boarded into a system. The reality is that about 5 or 6 things are actually predictive of a merchant that will default or that will defect to another merchant processor. And so if you can reduce that down to what really matters, then all of a sudden your operational processes are much simpler. The reporting that you get out of Perceivant is much simpler and cleaner, and you can pay attention to what really matters and not pay attention to the things that are just noise.
Okay, great. And let's see. I think we've hit all of the questions so far. I'm looking through some of the other ones. Very good answers. And just for those who are not terribly familiar, I think you just hinted on something that is really important for predictive analytics, and that is literally how you build the predictive models. And typically, and if I don't do this correctly, feel free to offer a better explanation, but you identify those key characteristics of the data set and you plot them out against each other to look for various patterns like spikes or valleys or that kind of thing, right?
Well, that's one of the traditional methods using visualization, and there's principal component analysis and a number of traditional techniques. We actually do something very different, is we go in without any domain expertise, without any hypothesis, and without any bias. So even with a very large set of variables, what we're doing actually at Emerald is we are creating tens of thousands of tiny little software agents that compete with each other in an ecosystem to answer the question on a subset of the data. And as they evolve through generations of mating and mutation and migration between subpopulations, that you actually end up with a tiny little software agent that solves the question very well, and that's something you can operationalize in Perceivant systems, and you can also view it as a human-readable model. And the big advantage of it is that we handle problems that, for example, would take 10 to the 45th years using the standard methods of identifying all the variables out of a subset. And those will typically take us 35 hours of computing time and about $5,000 worth of computing machinery. It's a very efficient process. As our CTO says, evolution, which is what we're doing, made people out of mud, right? So it's very effective, very simple, and the beauty of it is you literally do not bias it with any hypothesis going in. So regardless of what you think going in, you get an answer out that's objective, and then the domain experts can interpret that and learn from it, get insight, and then in Perceivant system they can actually put that agent into operation so it operates near real time on the data.
Okay, great. And one last question. It's a good specific question. Do your customers have to buy licenses for the software, or do you return answers in Excel or PDF form, or how do you actually deliver these answers typically, and what about licensing costs, or do you guys just kind of handle all that under the covers?
So overall, we look at licensing in terms of the number of seats of users that will have access to the system and the amount of data storage that we have. And if you have your data in a relational data system, our storage is going to be larger than what that relational data storage would be, but we believe we have very cost-conscious rates. They're very competitive in terms of the data storage part of it. And then when we look at the data scientist or predictive pieces, we look at the engagement, and then we will provide essentially custom pricing to the size of the engagement, and that's really based on the amount of hours of effort from our team and the compute resources required to produce the result.
Okay, great. Well, folks, we went a good bit long here, but wanted to get to those questions. Very good answers to the questions. Thank you so much to our friends from Perceivant for their time today. Thanks to Robin Bloor for his time as well, and thanks to all of you for taking the time out for another episode of The Briefing Room. We'll be back next week with Alteryx, and I can tell you, folks, next week we're going to talk about big data and making big data useful, and I can say that Alteryx has done a really fantastic job of creating a graphical service layer for dealing with all various kinds and shapes of big data. So that's going to be a really good webcast. Check us out for that one. Next month is Innovators, and of course 2013 is right around the corner. So thanks again for your time and attention, folks. We will archive this webcast. We archive all webcasts for later viewing. Go to insideanalysis.com for information on all that. And with that, we will bid you farewell. Speakers, hang on for a quick post-conference. Thanks again, folks. Take care. Bye-bye.